Добрый день, уважаемые дамы.
Good afternoon, ladies and gentlemen. It's time to start. Our panel discussion is called Trust as the driver for development or traction for digital technologies. Present today are Oleg Valinsky, Deputy Director General, Head of the Directorate of Traction, Victor Lesh, Director General of Sinara-Transport Machines. Kirill Semyon will be later. Kostikov Alexander, Chief Engineer of the Traction Directorate. Pavel Popov, Deputy Director General of NIAS. Andrei Romanchikov, Managing Director for the development of smart systems, Transmash Holding. Representative of Siemens. And online is expert Pyotr Skubilev, head of the chair of Samara Technological University, who will help us to address certain questions. In order to start the discussion, to trigger the discussion, I'd like to say that our industry, railways, is on the brink of almost revolutionary technological changes. But both in Russia and abroad, this is not just about technological and technical changes, but all the stakeholders in the market change the way they are working, they are communicating. I'm passing the floor. Without passing the floor, let's start a poll. Please vote using your smartphone, so you have to scan a QR code. Can you show the slide with the questions, and our online viewers are invited to vote. The question is the following. Technology's development changes the way the industry looks, and the future will not recognize that. But what technology would be the game changer? Remote movement control, artificial intelligence, digital transport of locomotives, which includes remote diagnostics, trusted environment and everything related to the data exchange, and other technologies. As an example, some renewables. So I give you a minute to do voting, and we'll see the results. What about the second question? The same technologies, but the question would be different. Which of these technologies would be implemented earlier than anyone else? The list is the same. Remote movement control or unmanned management, artificial intelligence management, digital platform, or other technologies. The first question is about the effect. The second is about the time of implementation. You have answered both questions at the same time. I see. I just not see that from my seat. Unfortunately, I do not see the results. Can I ask the organizers to spell out the results? Evgeny, there was no first question. There is no voting for the first question. Immediately we saw the second question. What will happen first? Well, organizers, the ball is in your court. The same technologies, but which one has most of the economic potential? The second about the time terms. The remote traffic control, 11%, digital platform, 25%. Artificial intelligence, again 25%, and other technologies, 33%. In terms of the speed of implementation, give me a minute. We'll show the results later. E-IDs or e-passports, these are the things which gained almost 60%. Oleg, I will have a question to Mr. Valinsky. Do you agree with the public opinion? There's 30-something percent which stood up for other technologies. What is it about? And to conclude our voting, I know that you work a lot in order to install these technologies in the Russian railways. Can you share success and problems? Thank you so much, Evgenii. Good afternoon. Despite the rainy day, it doesn't prevent us from enjoying the exhibition. Taking the question, whether I agree with the public opinion, certainly I cannot say that I disagree. Certainly I do agree with the public opinion. This is number one. As for other technologies are concerned, I will tell you later. I think what we were speaking about, it rests on the digital technologies. Whatever you take, it is associated with the digital technologies. It is a derivative of the digital technologies. And our main objective is to implement and install all these digital technologies as a unified ecosystem. Those smart services which we are gaining, which will provide not only the overview and storage, but we have information about almost everything. And everyone who is interested in that data, in that information, will be able to develop certain scenarios of actions or action plan. Let me tell you a few words about what technologies are being used in locomotives of the Russian railways. And this is the virtual coupling. And the first locomotives I've shown to you already. And back in 2019, in the eastern region, we started introducing these trains. And at the moment, we go on with that topic. Speak about today about 360 locomotives using that virtual coupling system. Until the end of the year, there has to be 668 locomotives. Bear in mind that we're buying new engines equipped with that technology, and our investment program also envisages upgrading of the available locomotives. As for the effects, you can see that on the slide. And today it's already been said during the dynamic show. Well, with the interval of 10 to 12 minutes, we can actually reduce this time up to 6 minutes. We are working in terms of point to point when the piloting locomotive controls the one which is subordinate to that. And we are doing our best that in 2022 we upgrade the technology the way that up to 5 trains can be controlled in terms of the virtual coupling. For us, first of all, this is about improving the throughput capacity in the eastern part of Russia or Trans-Serbian Railway, but we understand that locomotives are not the only bottleneck. We have to address the problem of power supply, how to prepare the infrastructure. And for instance, the switches have to be arranged the right way. This is the very first topic which is being discussed in the Russian railways. Another thing, which is nothing new, but it, again, something which we saw at Lastachka train for 4 years already. This topic is being tested at Lushskaya station, where we are testing 3 locomotives of T7, well, ordinary locomotives of T7A. But certain additional functions are installed, for instance, the automatic signaling system without the driver, the impediments identification system, and some other technological peculiarities are envisaged. At Lushskaya, we actually were doing almost everything automatically without human input. Also, that system requires further development because apart from that cycle, the hump engines, the shunting engines have to perform other functions which are not possible without a driver. The shunting has to be done fully automatically without the driver. And secondly, we have a whole program on implementing that system at other shunting yards. Also, in terms of reference, we have conditions when a certain system has to be developed, and the only thing it takes is to actually couple that with the infrastructure which is appropriate for such a system. So I think that in future we'll get a big fleet of locomotives prepared for the unmanned work. As for the miscellaneous or others, as far as I can understand, as far as I remember, all the time we speak about hardware, digital technologies which are being used for locomotives, infrastructure, etc. But at the same time, there is another quite important thing. This is the labor force, or people, how they are trained for the railway. And probably 115,000 of crew members are working in the traction directorate, and this is a big army of people. And their physical conditions, their competence, well, would determine everything, including the safety and security of traffic.
So, indeed, human capacity is something that is of priority to us today. And in terms of automation and management of rolling stock, those are important. Those who visited our today's expo, you would probably see that much of that expo and exhibits were about personnel management. You would be able to take another look of that. We have the comprehensive system of training and forecasting and support of personnel to assess the capacity of personnel throughout the career of personnel in a company, as well as identifying some risk groups and categories so that we understand what to expect of our employees in terms of possible violations. Based on the information that we get from the databases of various information systems of our company, we automatically generate the so-called passport of an employee with the history and with the assessment of the theoretical and practical knowledge of people, the performance data, some projections and of risks as well as the development programs and training programs to be offered to that personnel based on all the data analyzed. And this is all integrated with our simulation models means that would help us automatically check the knowledge of people, maybe also assign additional training to the employees if needed, and maybe going through training using the models and maybe trying to provoke those employees for violations and see the reaction and the adequate reaction of people to such offers. And all of that is put into the passport of the employee to provide a comprehensive assessment of the theoretical and practical knowledge of people, and so on. One more point, in parallel, we do have a service which is quite active today, which we call the personal office or the personal web page of the engine driver. And this is quite interesting. I don't know what to expect, but maybe today online through gadgets and through various devices you can get all the information needed that previously was available through the face-to-face training programs and etc. There are some special regimes of training that are put into this training program. I believe that this is actually quite an important aspect of our operations. Now, going back to the question of digitalization, another important aspect of our work is that we need to have this environment of trust for the engine crew. And by the way, we discussed that in 2019 at a similar venue, and there I referenced the quote from Klaus Schwab from his book of the Fourth Industrial Revolution, that in today's world the biggest value is trust. And of course the principle of reasonable trust really defines the development factor for our work and the Locomotive crew and Directorate. We are introducing and deploying various digitalization projects to automate and digitalize locomotive depots, and almost all processes now have access to that. There are some information systems, and the data, smart data available through such information systems may be running into terabytes of data. But there's challenges in taking any beneficially and mutually important managerial decisions would be not about availability of reasonable and adequate information. We do have adequate information available, but what is important would be to analyze such data to take any economically feasible managerial decisions at a given point in time, and as well as to monitor the implementation and execution of such decisions. Now, if you take the language of institutional economists, any opportunity attempts on any opportunistic ideas might be destructive to the environment, and this is something that I really face every day in my work, and we want to really get rid of that. And as I mentioned in the beginning, the solution would be to implement an ecosystem of the artificial intelligence environment of trust for the locomotive complex, whereby you would be going away from the hierarchical managerial systems to autonomous systems that can negotiate and agree with each other. If we have such an opportunity, maybe Evgenii, I saw Piotr online, and perhaps given the fact that he's in charge of the AI committee of the future engineering center, where the Russian Railways is one of the three stakeholders, maybe we can offer Piotr a chance to talk about the future developments of this artificial intelligence-based system. Piotr, would you like to take the floor? Yes, thank you, colleagues. Good afternoon. Then, if I may, perhaps I would ask to share a few slides of mine to explain the ideology and ideas that we are trying to propagate through our training center, which we call the Future Engineering. And in the meanwhile, I would like to say that what Oleg was talking about, and I mean the philosophy of partnership, the reasonable trust, the environment of trust, not for, any post-factum analysis or record keeping, but rather for prompt decision making. You would think that this is all quite understandable, but this is rather a huge challenge that you cannot really take through traditional methods and tools of Industry 4.0. Now we're talking about some coordinated collective decisions to be made by program-based robots and different systems that need to really handle hundreds of thousands of those decisions every minute. I wonder if you see my slides, by the way. Yes, we do see that. I'll try to be quick and trying to explain the key principles that we are guided by, and perhaps then we can have some Q&A and discuss those principles. One more, please. There you go. Now we're talking about a transition to environments of trust, to platforms of trust, to manage the life cycle contracts. Now, what we are hearing today is that this is about interaction, about the different participants in this cycle. It is quite difficult, and there's nobody in charge, so you need to agree with each other. Everything is transparent and everything is changing. And you have diverse demands and interests coming from all points of the compass. And of course, the institutions and participants need to receive intellectual systems that would employ the representatives, and they should be also part of the common centric platform where they can interact each to each and equal to equal. And this would create an open digital ecosystem of managerial intellect. And this is required to provide for the full transparency. And it is not about the analysis of historic data, but it is rather about making decisions for future with the real costs appreciated and assessed so that you can see the developments in real time. And that would produce an economy of solidarity that I'm going also to discuss later. Now let us take this very idea of emerging intellect. This is like ants, an ant hill, and they actually interact and create very difficult systems with emergent-like intellects, and that would help them make decisions on ever-changing and complex tasks. So based on such approaches, we can see the emerging transition to the future from the traditional systems, which you can see on the left-hand side, where you have a hierarchy where people are passing information on, and where they make decisions. And we're transiting to an ecosystem-centric architecture where the program-based, software-based robots would be making decisions. But can we really produce such a system today? Yes, and we're talking about multi-agent technologies that help create agents, say, for a locomotive, for an engine, for a crew, for a station, for a section of the road, etc., etc. And the knowledge that is used by the agents can be made separate of the software code, and that would be part of the ontology and the semantic networks. By the way, we're talking about going into the Industry 5.0, where the AI systems would create colonies or collectives, and we are now operating with knowledge but not data, and such knowledge is required for collective and concerted decision making. Based on all of that, we developed some first vision of such a system, of this emerging AI, where you have different systems in charge of the different steps of the process. They are based on platforms, and where the data presentation platforms and the protocols of interactions, they are all in the knowledge database, and where you have the continuous interaction between the members of such a system, more or less like a roundtable discussion. So we're talking about twins of enterprises, digital twins, and digital twins of specific products. And we're talking about thousands and millions of decisions being made real time. And hence, in this system, you can see just one day from the life of an engine. It would have an account in the bank, if you like, to take orders and also to pick up the resources required using the smart contracts or any related technology. Say our engine received 3 orders during the day, and then it paid for the parking. It was consuming some resources, so we have costs and we have profits. This is a microeconomy of costs and profits and income, and this is based on the life cycle of an engine. Now, this makes it possible to come to the main point here. We would like to really accelerate and see beforehand the full life cycle of such technologically complex items as an engine. And here you have 2 examples of 2 engines. The red one was actually cheaper in design and production and manufacturing, but then you have some key points which are green there. But it actually started to produce more income, went to the maximum, but then the profits were going down because of the failures and other problems, and that engine actually came back to the point of cost recovery, and actually the life of that engine ended in the red. So it actually produced losses to the owner. The yellow engine actually was more expensive, and it actually was producing more profit, and actually it ended its life cycle when the engine was still in the blue or in black, and more or less it was still producing some profit for the owner. So you can do the same for different models, for the different sizes of the economies, and we see it that any smart thing would have an economy and would have a plan coordinated with the services, where the services are coordinated with the items. Prices are dynamic, depend on the specific circumstances, and the cost and benefit analysis is available not for the system as a whole, but for each of the companies and members of that system. And there we can have this unique opportunity of a virtual joint enterprise for each of the items, and the parties would no longer be trying to defend their own interests, and we see the overall picture, and the economy is making decisions to influence the actions and decisions made by the agent. And this system is recursively fractal. You can deploy it in any level of granularity needed, all the way to the nuts and bolts level. Thank you for your attention. I'd be happy to, take any questions or to maybe provide more arguments and comments on this vision of transformation and whether this roadmap really has any chances to be implemented in practice. Thank you, Peter. And indeed, perhaps we are not going to really go into any virtual debate with you, and I would rather give the floor now to the vendor, to Victor Lesh. What do you think about this environment of trust, about this communication between the smart things? So what do you think and take of this? Well, I would not be providing any arguments or argue with somebody, but I rather would support Piotr, and I would not be using those very difficult and complex words and terms, but rather would simply say that we have done something already in practice, so that this idea would be kind of like embodied in various tools that we can use on this very difficult road that you pictured for us. What we need to be thankful for, we as the vendors of the Russian railways and the various departments, is that back in 2016 we started this difficult way of the contract life cycle. We actually started from the scratch, and more or less we had kind of like a collection of various automation systems and information systems and various databases which were not really integrated into any single whole. So in the first 3 years, I would say, until 2019, we tried to solve a difficult task to really make sure that this keyword of trust be operational, and that was really instrumental in our interactions with the customer. Probably not all really carry that spirit, and maybe we are not trusting each other by 100%, but still, that environment of trust and all those smart gadgets, a priori, because of the excessive information that is available from them, information that you cannot really verify or source out, you a priori would not really trust such data, because you don't know whence such data, and you probably do not trust whoever handled such data before you. Now, Oleg, despite the fact that they all had gadgets and we all saw the results of the voting, we all more or less had those on our screens in front of us, but we still kind of like turned it around and to check the main screen to check and verify. So this mistrust is still with us.
Проще жили, что ли?
We used to live a simpler way in our trusting atmosphere, and it means that we did a lot of work. Among the manufacturers and the servicing companies which are maintaining the locomotives following the life cycle contracts. I am just mocking. Well, we followed this algorithm starting from 2018. Once this trusting environment was mentioned, we started to find the ins and outs, what it is about, how can we affect it, whether it's a kind of a tool of a doomsday when the guild of the manufacturer or the servicing company is being established for the failure of the locomotive. We found that balance, and it is not fully equipped in order that the trust and confidence works 100%, and the algorithm is not full. But I think that this is the life cycle contract that made us deep dive into these digital processes. We spoke a lot about that. We started working on the Smart Locomotive project, and we started working on the servicing contract. So there are certain nuances there. For instance, the mileage data now is available only from the static data system. We cannot online get the mileage information, and we cannot take proactive decisions. It's rather difficult to be done, but still we found a way to exchange data between different systems, how to process this data. And these two settings are interacting, and now we can more accurately plan our actions. The linear systems, these are the projects which are being implemented in the digital depots, and it goes without saying that this is quite useful to understand what we are doing, why we're doing that. And the algorithm which was mentioned by Peter, it has to be detailed until every nut and bolt. And every locomotive now is being introduced into the lifecycle contract. The outages and failure statistics, I think this is one of rather difficult things and moments. This is a kind of a gray zone, and we have to speak more about that. We have not defined the notion of outage and failure. Our customers may understand that differently. And we have to work further on that, and it will bring us closer to the trusting operating environment. Until we set an agreement with the control rooms and the safety departments, the transportation planning department, so we will not move forward. This is not our function. This is a kind information on the intersection of those two fields. As for the predictive modeling and diagnostics, so these tools work very well. We started that as a pilot project end of 2016, early 2017, and we achieved quite decent results. And we are trusting these results, and we can get that information online from the board of every locomotive, and we can do some predictions following the key components, such as the traction engines, for instance. And this helps us very much in winter time, just in order to calculate the algorithm and to predict the impact of the weather and how it may affect the traction engine. We don't have much data. The figures are frozen. And next step, we have to be prepared for processing big data, and that is really true. Well, in brief, I'd like to stress that once again, that, and without any flattering, it won't be a stretch to say that digital, that's the main driver of progress. We represented a company which participates in the production of the rolling stock and traction engines and cars, lifecycle contracts, and similar approaches to that situation are being promoted in other fields as well. We understand that this would influence our efficiency in all the processes, and we are doing business all together. Just not to be a peasant, let me push the button myself. What we voted for? We voted in favor of some smart locomotive, on board of which you'll find several systems, and our customer came up with these requirements, with these terms of reference, and did that very clearly. And Oleg Valinsky spoke in every detail about that. The prognostication and predictive maintenance systems have already been installed in the locomotives, where this may be fine-tuned. Virtual coupling systems are being implemented, and I think that the Locomotive 2T35 will boast the system of transferring the data from the locomotive to the control officer. Otherwise, it would remain just an option if it isn't required by the customer. Machine vision. We have a joint project for TM14 with new diesel engines, number 8185, and we expect from VNIAS, we expect in November necessary systems, and we can create a prototype for testing. I don't think there will be any problems, and we will help make this project come true. A few words about diagnostics. Locomotive, in essence, this is a diagnostics facility. Before, it would diagnose itself, and for 2018, early 2019, we decided that Locomotive could diagnose the infrastructure. It should see other trains as well, understand their conditions, and proceeding from that, it would give certain message, monitoring and controlling the speed regimen, etc., etc. The diagnostic system is going to be improved further on. We do hope that the technical terms of reference would be prepared by the customer. And once Mr. Belozerov did the on-site inspection, we discussed that. And I just think that we have to make a roundtable discussion of the terms of reference. Locomotives which would be made starting from the first quarter next year would be equipped with that system, and therefore, instead of having to buy a diagnostics system separately, you would be able to use conventional locomotives, and the Russian railways would get all the data necessary for prognostication, and we didn't make a lot of progress in that field. The locomotive has to be closely connected with the on-site systems, the ones which already been installed in the Russian railways infrastructure. We are doing our best, and I hope that this work would be done efficiently end of next year. Thank you so much. I'm done with my presentation, ready to take your questions. Thank you so much, Igor. So let's just, before we start Q&A session, let's listen to other speakers as well. And Ivan, we heard about big data being collected, which could be used. And what's your attitude towards obtaining that information and using that information for the sake of operating locomotives? Thank you so much. To start with, let me say a few words about big data. That's a myth. That's a stereotype. Once we speak about the rolling stock, at the moment, we don't have any big data about rolling stock. The data which we're collecting is not sufficient in order to train the artificial intelligence, and based on that data, providing certain predictions which will come true 99% or 100% of certainty. We have lots of data, but the expert component is clearly very much important, and these data have to be verified by experts. This is the approach by Siemens. We had an experience when our IBM acted as one of the competitors, and it offered the data processing solution in terms of processing of big data. IBM certainly is the pathbreaker. It is an unchallenged leader, but the situation is more complex than that. Without expert analysis, data alone is not efficient. Secondly, Siemens, some time ago, recovered from that disease, meaning that they no longer were inclined to collect all the data possible. So the initial data accumulation stage is over, and now actually they are not so excited about data collection or data acquisition. Some of our partners and customers who invested heavily into some meters and other systems of data acquisition, who invested into that, they now frustrated and disappointed in that approach. So they say, we have invested a lot, but where is the payback? So digitalization is quite fashionable, but economic efficiency is even more important with all the digital solutions. We are just scratching the surface of 50% of efficiency remaining that will give extra value to the business. And 80 to 90% of business efficiency, that's about training of the personnel, that's about upgrading of the equipment, etc. Unfortunately, this is not fashionable to speak about that. Everyone speaks about innovations, but we prefer to use the existing approaches, and we try to use the potential of the systems which are available. Locomotive with asynchronous traction is designed to work with the heat recovery or energy recovery. So it means that this power recovery has to bring us some fruits in terms of environment. Once you have a locomotive and there is no trained mechanical engineer or no spare parts, online data will not be helpful. So you would provide, you would get that information, but the locomotive would stand still for a week's time expecting a repair. But our GSM coverage is not very good in Russia. Therefore, transmitting big data from the board of locomotive is totally not very much inexpensive. That's it, I think, in terms of digitalization. Probably this is not what the moderator expected to hear from Siemens, but that's true. And very often when we approach some of our external partners, they ask us, do you want to offer certain meters, more meters? And we say no, by no means. We are confident that you have much more information than we expect you to have. If you look through the slides, you will find a lot of solutions how the available data can turn into information. For instance, once you don't have certain vibration meters installed on certain elements or components, you can always use some thermal sensors or meters which are cheaper. You can analyze some systems in order to predict the behavior of more expensive systems without using sensors or meters. Certainly, there are certain systems available, and once service speaks about the lifecycle contracts, this is what we support wholeheartedly. Russian railways are shaping the market, and therefore it prompted the market to embark on digitalization, whereas elsewhere, digitalization, that's about business tools. Once you have a lifecycle contract, you have signed that. This is in your best interest to introduce predictive analytics, to install the systems when you are booking the spare parts in advance. And so once the locomotive actually is working, is approaching the station, you already can pre-order the spare parts and you can sign the work order, for instance. It should give some added value to the business, and certainly the life cycle contract. That's the main driver, which is very helpful in terms of implementing all these solutions. And you would understand actually how much money you spent on that and what the feedback would be, what the payback would be. This is all I could tell you about how Siemens approaches digitalization. Ivan, thank you so much. Some say that 80% even more of information is never used. We do not know actually how to derive value from big data that we accumulate. I will agree with what you've said about frustration, overall frustration of collecting data of everything and about anything. My question goes to Mr. Kostikov. You are working on the e-passport of a locomotive, and prior to the session we tried to calculate how many data, how much data is being collected on a days basis or on a yearly basis. Can you tell us about the progress made in terms of the e-passport of a locomotive, and what challenges are there? Well, digital technologies within the corporate strategies helps us not only to follow the fashionable tendencies, but to save up money. Digitalization have embraced all the fields of activity of the traction directorate. One of such areas is an automated system of an e-passport of a locomotive created by our experts. What this passport is about? This is a single data storage system. It stores the data of all the events, all the nodes and components of the locomotive, the repairs data, etc. Well, actually, we have about 11 million such e-passports at the moment, and this system is being used by 15,000 people. The e-passport of a locomotive has all the advantages of an automated control and inventory system. Therefore, we get diverse predictions and forecasts. This helps us to optimize the repair and maintenance.
And this also helps to more or less allocate financing appropriately. We can also take some managerial decisions properly, and we also introduce some barriers that would prevent, launching a malfunctioning locomotive online. And we are also tracing the assets of Russian railways using RFID markers to show the movement of all spare parts and linear equipment from the moment of manufacturing to the installation and removal from the engine, all the way to the disposal of such equipment. And this is makes it possible to actually have an end-to-end monitoring in place, which guarantees which makes it possible to really make sure that the locomotive has original spare parts or any items that have been approved for issue. However, the main purpose for the locomotive of this locomotive passport is to really manage the finances in terms of putting the movement of the locomotive and reconciling the movements of the locomotive with accounting data. The interaction between two systems would help us get the right information about the rolling stock and properly manage the procurement of spare parts, which really optimize the life cycle of locomotives. So we talked to Pavel. What about the massive of data that should be loaded into the electronic passport, and what should be there? So depending on the type of repairs and maintenance, it goes from all the way from 30 to 100% of all the requests for maintenance. So we actually provided passports for the equipment that is most required during engine maintenance. I'm done with my presentation, and I'm happy to take your questions. Just one point so that our audience would understand. 11.5 million passports does not mean that these are the 11.5 million engines. No, because those also cover various pieces of equipment installed in the engines. My question is next to Andrei Romanchikov, and one of the most popular questions was what would be the disruptive technologies for the industry, like the remote control and unmanned locomotives. I know that you are more or less in the business of unmanned locomotives, and probably you can really share with us some ideas. Well, yes, thank you. First of all, I would like to welcome all of you, and I would like to comment on all the options for answers that we started to discuss. What are the technologies might change the vision, and what are the past technologies and future technologies? But nobody is actually asking whether we need those technologies. And seriously, this is a big thing that today in 2021 we are no longer discussing whether we need digital technologies at all, whether we need the digitalization of the rolling stock, whether we need the environment of trust. We all understand that it is a given. This is something that is required, but the only point of discussion is how to make sure that we deploy it fast. Now, regarding the remote management and unmanned engines, this is quite interesting. We do not have any, one universal answer to that. And if you really take the economics of such technologies, the payback period for such technologies, taking into account the cost of investment into the infrastructure, so the payback period would really start on year of 50. For even MCD, we do not really see that the payback time would come earlier than 50 years into the future. But we still believe that, in general, automation might help us to manage and handle machines better than humans, safer and more efficient. And this is a fact already. At least I cannot hear from the audience that this is not so. And the absence of humans is not a problem, but technologies can really handle the machines better. Well, today in the morning, Oleg Valentinovich was asking about the use of artificial intelligence for engines, and the question was whether we are using AI for the traction, and I said no. And he asked why. Because we believe that the algorithms that we have today, that more or less are based on the safety curves for the optimal movement, would have dozens of years of inputs and research from various think tanks and schools that we cooperate with. And we believe that these are the technologies that already today make it possible to operate machinery autonomously and without the contribution of humans. We think that AI and some elements are needed, of course. If you take, say, machine vision, and Alexander will be telling you more about that, and we are doing something in that area. We are introducing the AI systems there, but we still believe that it should be quite a symbiotic relationship between the algorithms of driving an AI in terms of machine vision. If you take the digital platform of an engine, this is not the question of time. We are already there. And of course, this is something that has been implemented, and you could have voted for that, being 100% confident. Because, of course, I mean, you cannot say that we are done with the technology, it is now ideal. No, technology would always develop and evolve. But on a larger stake, we can make the diagnostics of an engine, of a locomotive online, and nobody kind of like is surprised with that. All the locomotives are produced by Transmash Holding already have the Kovchek system on board, where you can see the technical status of the locomotive online. We, as a TMH, I would like to, share with you where we are in terms of the technologies that we discussed, and we are following the way of developing such competence in-house. So this is not really kind of like a solution that is supported by everyone, but it is actually caused by one factor. We think that digital technologies hold the future, and we, as the vendor which is responsible for the life cycle of machines and for the maintenance of machines, cannot really have a black box installed on the locomotives where we do not understand how that black box works. Evgeny asked why we're doing that, and we're doing that precisely for that purpose, to understand and know how that black box works, because this would define to a large extent how the machines and engines are operated. And of course, we are using the virtual coupling and the online data transmission technologies, etc., etc. And we think that the biggest value of TMH is the algorithm of traffic control. Of course, we can take Siemens, but we can take other ways of getting data there. The thing is that in 2 months, we would not be able to adapt the technology of data transmission too quickly. We're also doing we are producing the safety cages. Many are not happy about that. That's why we are doing that, because we cannot afford having a black box on our engines that we do not understand. Same is true about the machine vision, and we do cooperate with all the think tanks and research institutions, and we're doing that just because we understand that any machine should be looking forward and should be learning, and that is why we are investing our money there. We are dealing with those technologies. Regarding predictive maintenance, then much has been said about that, but what is good about that is that it is, of course, to the merit of the customer that we can claim that this is a story which is with us, which is already in place. It is not about any presentations and slides and pictures, but you can really see that in real life. Colleagues, thank you very much. Thank you, Andrei. Well, much has been said here that without any onboard control systems, there won't be any future. How do you see the development of such and involvement of such systems? So what are you doing there? Colleagues, let me try to be brief about the challenges that we are facing. We actually discussed those technologies and voted for them, but engines, locomotives have many systems and devices installed on them from different vendors, and we have a set of those devices, which makes the life of fine-tuning those devices and systems quite difficult. We would add another system to the core system, etc. We talked to NAMI, and they said that it is very important to have an architecture in place for the engine. Now, a few words about the trends. The railroad people, including from Europe, are saying that you have a CAN and 485 interfaces with different latency times and delays, and you have all those systems in one place on the engine. And this is a universal problem for many of the industries. And other industries understand that there needs to be some reconciliation between them. And Europeans said that we don't want really to develop our own systems, proprietary systems. They would be looking at other industries like the car making and the aircraft making, and they are using TSN buses on the engines for the onboard systems. So that you would spend a minimum time for fine-tuning and maintenance. And in Europe, they actually have such a group. You can find it quite easily on the internet. It is called Acora. And almost all European companies, operating companies, NSCF and Deutsche Bahn, etc., they more or less pull their effort together. And they said that we do not want to depend on others. And that Acora group said we don't want to depend on other big vendors or big railway companies, because once you install the system, you won't be able to replace it, and any replacement is quite costly. So that Acora group said that we actually introduce some requirements for the system architecture and protocols with open access. You can take a look at those, and actually they are preparing tendering documentation to determine what kind of systems need to be installed. And say machine vision, they actually define the physical and functional architecture of such machine vision, and they actually defined how to interact with that. Many difficult points there, so the trend, the key trend there is that we need to have an architecture. So inside the engine, inside the locomotive, we need to have an interface and data transmission diagnostics, which is done quite differently by different vendors. In Europe, it is more synchronized. And of course, railways are behind the car-making industry. Take the after-SAR system. Almost all cars are built around this project. But there's another question for the railroads. They would have their own computing devices and modules, but some are saying that there should be one single API interface with optimization. It's a difficult way, it's a difficult path, but this is the path not only for the railways, but for all industries. And many things can be transplanted from the trends and ideas that are floating around. And those trends would really help us with easier fine-tuning and commissioning of devices. Of course, our safety devices are quite different from Acora's, but the general approaches are quite important. That internally you need to have very clear architecture, and they are also offering a framework for data exchange between different devices to really simplify the competition between the devices at the level of a single locomotive. Thank you very much. And the last speaker for today would be Kirill Simeon. And Kirill, I have a question to you. Almost all those speaking today mentioned the foundation of your department. Mentioned something which is related to the core business of your department. Well, maybe I won't even exaggerate to say that in a number of years, your department is going to be the key department in the Russian railways, because everything would become remote and digital. So, what are your priorities? What are you going to really work on in the near future? Look, first of all, good evening to all of you. Based on what my colleague said, I'm afraid that my department is not going to be the only and key department, but something that is not needed anymore, because everyone is kind of doing a great job of handling those digital technologies by themselves. I am appreciative of my colleague from Siemens that Russian railways are actually stimulating and incentivizing the digital services market. I don't see any negative about that. The company for itself has determined a list of questions for digitalization to be implemented that would have some effect. So if our partners in cooperation with us would take similar decisions and deploy similar solutions, we can only welcome that. When you're asking the question of what are the priorities are quite simple. There are many of those, but down to earth, I mean, it's internally and also externally, we're talking about the building of those ecosystems. A hype of today, but many people mean different things about ecosystems. Mr. Moore actually mentioned that first, but ecosystem is more or less like interaction between different subjects who run their own business and their own economy. The building of an ecosystem around the digital technologies in the Russian railways is one of our priorities, something that was mentioned by Oleg and others and before us during the session about digitalization. So this is exactly the story that I'm talking about. And let's be frank, digitalization today is more about data. What colleagues actually talked about. We can talk about some sufficient level of information systems and availability of those data, be it in Russian railways or elsewhere. But unless you have full and good quality data, any solutions and decisions that you generate in those IT systems would more or less be worth the quality of data that you use for such decisions. That's the story. Now, one more thing. Indeed, much is being said today about trust, and indeed, this is the project of the environment of trust, and we launched that, and this is the environment of trust to really simplify and make more efficient this interaction between, in essence, the companies that have not really different business priorities, but they have their own economic interests. And our service companies and our vendors and the Russian railways, they have their own economic interests.
We have to build an environment which would take into consideration the interests of every stakeholder with single and transparent rules of the game. That's the main purpose, that's the main objective of this trusting operational environment. Cargo transport following smart contracts are singular, but really take place, and they executed the right way, they are maintained the right way. And in essence, we see interaction between the manufacturers of locomotives and Russian railways and the consignors and consignees. As for the multi-agent systems, I do agree that the future belongs to it. But that would be the future. And in future, I'm always a little bit against speaking about artificial intelligence in general, because at the moment there is no artificial intelligence, but there is the AI technology. AI cannot be actually the right holder. Someone has to be responsible for that. Until today, at the moment, besides believing in the bright future and getting prepared for that, and we are improving the multi-agent environment at the moment, at present, any solution has a name, last name, and a patronymic, the one who has to be responsible for that. And that's not the artificial intelligence, but the one who entrusted it with something, who decided whether artificial intelligence is to follow certain instructions. Therefore, we are focusing on the expert systems, and that's a difficulty. There is a difficulty in the sense that it's difficult to interact with the partners, with the stakeholders, and to interact within the company. Any expert-based system rests on the transparency, what is good, what is bad, why one thing is better than the other, and vice versa. And the rules of the game have to be transparent. So no artificial intelligence system, no technology of the artificial intelligence will not be trained in a situation when the same question, 2 plus 2, and you come up with 2, tomorrow with 5, and the day after tomorrow you come up with the answer that it is blue. No one system can be trained. And summing up what we discussed today, this is all about trust, the trust to the data that we have, the trust to the data that our partners have. But potentially, I believe that later on we eventually will trust each other so much, and we are making progress on that. We will trust not only the set of our data and our data combined with the data of our partners, but we'll have unbiased analytic systems based on these data, the way that we will trust the results obtained by the analysis of this data, and we'll interpret these results the same way as our partners do. So we have same way of interpreting conclusions made out of the information that we have to enrich each other with. These conclusions would be mutually acceptable, appropriate for everyone, and this will drive our efficiency and improvement of our business processes. And I apologize for a little bit stilted speech. Thank you so much, dear colleagues. We are behind the schedule, but I suggest that we allow for a couple of questions, either from the floor or from the panelists, following what we discussed today. So we have time for a couple of questions, if there are any. There are no questions and everyone is tired. Just let me share a couple of statements. While Mr. Simeon said, I just imagined how artificial intelligence may talk to the prosecutor. Once actually the prosecution office also embarks on the artificial intelligence, that would be communication between two types of artificial intelligence, and they would be never tired of talking to each other. To wrap up, first of all, we all prove to each other that the main purpose, actually, it doesn't make sense to add more sensors and meters to the systems. We'd rather manage the data information the right way so that we can come up with some efficient solutions satisfactory to every link in that chain. Second conclusion, I have proven to myself that there is a problem of trust and confidence in our relations. This is what we heard. And to conclude, let me quote from what's been written. That's an article by Andrei Sharonov, published in the Forbes magazine. GDP of Russia can be 69% more once we have the trust and confidence like in Sweden. So 69%, I think, is an accidental, is a random figure. This is not the topic of today's discussion, and we can discuss that separately. Thank you so much. Well, let's try to achieve the level of confidence like in Sweden. I thank all the panelists. Thank you so much. Those who came offline today to discuss these burning issues. I wish you a good evening. So the meeting is adjourned.